Hello everyone, welcome to my chemistry channel BL Short and Sweet in Chemistry. Now it is short revision of electrochemistry and here the topic is points to be remembered. What is mean points to be remembered? That means after reading the whole chapter, after studying the whole chapter electrochemistry, what are the main facts? What are the main points to be remembered? That one I want to discuss. This is part 18 and for class 12. So, what are the main points? From the beginning of the chapter, I want to going to start. First point, what is electrochemical cell? You already read, but again you see and revise yourself and try to remember yourself. An electrochemical cell consists of two metallic electrodes dipping in some electrolyte solution. It is clear, already I told, it is a two metallic electrodes in a electrolyte solution. And chemical energy converted to electrical work. What is the meaning? Chemical energy converted to electric work. Can you remember past? Example, galvanic cell. In an electrolytic cell, electrical energy is used to carry out non-spontaneous redox reaction. See, what is an electrochemical cell and what is an electrolytic cell? Here, the electrical energy used to carry on the reaction. What is salt bridge? Salt bridge in a galvanic cell complete the inner cell circuit. That means that is the main connection between two beaker where the electrolyte solution is carrying, and here inner cell circuit is completed. The standard, what is mean standard electropotential then? That means dipping in a solution is calculated with respect to standard electropotential of hydrogen electrode taken as 0. Standard electropotential for any electrolyte, that is compared to standard electrode potential of hydrogen electron SHE, that is taken as 0. That means you will compare with for the calculation of standard electrode potential for any electrode to the SHE, which is taken as 0. E0 cell equal to E0 cathode minus E0 anode. You also, I hope you remember this. E cathode should be a higher value than E0 anode, so that E0 cell is positive. If E0 cell is positive, then it is good working, and if E0 cell is negative, that means cell is not working. A relation between electrode potential and concentration of electrolyte solution. Concentration, moles per liter. Then here concentration, how it is related to electrode potential. This is the known as this is called as the Nernst equation, where the you see the how the reaction takes place. M plus N means number of electron. That is N is the number of electron, that is Ne minus, so it is becoming Ms. M means metal and S means solid. So what is the equation then? This is the reaction, this is equation, that is N is the number of electron, very important. So E M plus N, that means here this is the electrode potential value. Then E0, it is E0. E0 means standard potential M plus N by M minus 0.0591 by N. When you divide all the digits, then you will get 0.0591 by N. What is N? N is the number of electrons. That means when the reaction is going on, here number of electron is very important. So minus log 1 by m plus n aqueous. That means here the concentration. What is the square bracket meaning? Molar concentration. So this is the equation where n is the main factor, that is the number of electron, and here the 0.0591 by n, that is the second one, and third is here molar concentration 1 by m plus n. So here then come to, for galvanic cell what happened? Galvanic cell E0 means electrode potential of the cell. E0 cell means electrode potential, that is standard, minus 0.0591 by n log anode concentration by cathode concentration. Remember, anode concentration by cathode concentration, that is log anode by cathode. When the concentration of electrolyte solution is different, when the concentration is different, and then what happened? E cell equal to RT by NF ln C2 by C1. What is C2 by C1? See the concentration of two electrolyte and the solution, and C1 is the concentration of electrolyte solution 1. Then what happened? E0 cell equal to RT by NF ln C2 by C1. EMF is positive when C2 is greater than C1. Remember, we required EM should be positive, otherwise it has no value. So EM is positive when C2 is greater than C1. So this line is very important. Suppose in this objective question is asked, C1 is greater than C2, then what happened? Or C2 is greater than C1, what happened? You should see if positive, then this is the case. Okay. Equilibrium constant related to next equation. Equilibrium constant means Kc. What is equilibrium constant? Kc. All things you read before, only you revise. E0 cell, 0 cell means standard electrode potential equal to 2.303 RT by NF log Kc. What is this? This is not clear, I think. This is Kc. So 2.303 R value will put, T value will put, and all value will put. Then Kc is calculated as anti-logarithm of the sum value. Then here E0 cell equal to 0.0591 by n log Kc. So here what is the new factor? N is the number of electrons in overshell reaction. Here you can observe how will you calculate Kc. Then you should know all the values. Then next you will take the anti-logarithm. Maximum work. What is maximum work? Work done by the cell is equal to decrease in free energy. It is coming to thermodynamics. Work is done by the cell is equal to decrease in free energy. So delta G equal to NFE. So here no standard value. So from delta R G 0, the standard. One can calculate the equilibrium constant. So del G 0, standard value equal to minus RT ln Kc. So it is what happened. You put the value or value, then 2.303 RT log Kc. So here minus 2.303 del, this is del RG0 standard 0, and that is equal to minus 2. Ln means 2.303 log. So we put the value minus 2.303 RT log Kc. So what is the next one? 10 point, resistance R. Resistance is measured in ohms. It is directly proportional to length, inversely proportional to area of cross section. So what is the formula? R directly proportional to L by A. R equal to rho L by A, where rho is the constant called resistivity. The unit of resistivity is, you should remember repeatedly, ohm cm, or that is ohm cm. This is the sign. The inverse of resistivity is called conductance. Inverse of resistivity mean what? Rho. Rho is the resistivity. Inverse mean 1 by rho. That is called conductance. Are you clear? These all are the same thing. What it is only repeated, and try to remember all the points, important points here. Then G equal to 1 by R. The unit of conductance. Unit of conductance equal to, that is ohm inverse, that is mho. The inverse of resistivity called inverse of resistivity is called conductivity or specific conductor or kappa, that is representation kappa sign. Again see, the inverse of resistivity called conductivity or specific conductance represented by kappa. L by A is called cell constant and represented by G star. Molar conductivity, cell constant mean what? G star. Molar conductivity and lambda is defined as conducting power of all the ions produced by 1 gram mole of an electrolyte in solution. So 1 gram mole of the electrolyte in solution, what are the number of ions produced, and that conducting power of all the ions. Molar conductivity increases with the decrease of concentration, that is on dilution. Molar conductivity increases when the solution is very diluted. Strong electrolyte with dilution, see here, strong electrolyte with dilution, inter-ionic force are expected to decrease. When strong electrolyte dilution happening, you are making dilution, then what happened? They expected that is inter-ionic forces to decrease the ionic mobility, that is increasing, so resulting in increase of molar conductance. What is mean? Molar conductivity increases with decrease of concentration on dilution. Then a two electrolyte, strong electrolyte dilution, inter-ionic distance expected to decrease, and the ionic mobility increases with also increase in molar conductance. Then come to weak electrolyte, then what happened? They say the formula, then you will see here, lambda C equal to lambda M infinity minus A root over C delta MC, that is molar conductivity at particular, C mean at particular concentration, and infinity mean at infinite dilution. C the molar concentration of an electrolyte, A the constant depending upon the nature of the solvent and temperature. Remember, this is very very important for the weak electrolyte also. So this is the, if concentration C, then what is called molar conductivity at particular concentration. If it is the infinite sign, molar conductivity at infinite dilution. And what is C here? Molar concentration of electrolyte. What is A here? That is constant depending on the nature of the solvent and temperature. For weak electrolyte, what happened? On dilution, molar conductivity increases due to increase in degree of dissociation, and that is here that side. A strong electrolyte, inter-ionic distance decreases, and molar increases due to increase in the dissociation, this degree of dissociation. See, both are having same answer, but same, the region are different. For weak electrolyte, that is molar conductivity increases due to increase in degree of dissociation. Then alpha is the degree of dissociation, then lambda m by lambda m 0, that is infinity. Okay, you can write infinite sign also, though alpha is the degree of dissociation, that is very helpful in weak electrolyte. Then lambda m molar conductivity at the concentration, and lambda m0, that is molar conductivity at infinite dilution. You can put also 0 or infinite sign. Dissociation constant of weak electrolyte, that is K. I told dissociation constant is very important for weak electrolyte. This is represented by Ka, that is equal to C alpha square by 1 minus alpha. C the concentration, alpha is the degree of dissociation. Then come to 18 point for strong electrolyte. And for strong electrolyte, what happened? And lambda 0 NaCl, that is, since it is completely ionized because it's strong electrolyte, and this is the case, you will see here lambda 0. 0 or infinity sign, same meaning, plus lambda 0 Cl minus. Suppose 100 are there, 100 NaCl, then mean 100 Na plus 100 Cl minus. Yes, that means here for weak electrolyte, what happened? In infinite dilution, molar conductance cannot be calculated easily because it is weak. Electrolyte is not completely ionized. That is why at infinite dilution, molar conductance cannot be calculated easily. Then what law you will follow? Coriolis law, which is applied to the calculate molar conductance at infinite dilution for weak electrolyte. That means weak electrolyte, main point is weak electrolyte is not completely ionized. That is why you always see degree of dissociation. How to calculate the molar conductance for weak electrolyte that at infinite dilution, and that law which is following here, Coriolis law. Faraday's Coriolis law, the explanation already done, only the important facts are written here. Important facts I want to show you. Then come to Faraday law of electrolysis. Faraday, the scientist who provided two laws, that is, if W gram of the substance, listen carefully, is deposited on passing Q coulombs of electricity. If Q coulombs of electricity is passed, then what is the law said? W proportional to Q, and W equal to ZQ. Z is the electrochemical equivalent. It is the first law of electrolysis. Again, you want to see here Faraday's law of electrolysis. If W gram of the substance is deposited, remember, if W gram substance deposited by passing Q coulombs of electricity, then this is the formula. It is the first law of electrolysis. If the electrolyte solution are connected in a series, suppose there are two electrolytes are there, then the solution is prepared and connected in a series, then what happens? Weight of copper, lead, copper and silver. Weight of copper deposited, and here divided by weight of copper silver deposited. That means weight of copper deposited by weight of silver deposited, that is equal to equivalent of copper divided by equivalent of silver. And what is this? This is the depositor. So by passing Q coulombs of electricity. This is the second law of electrolysis. So again see, when the electrolyte solutions are connected in a series, example copper and silver solution, then weight of copper depositor divided by weight of silver depositor equal to equivalent weight of copper divided by equivalent weight of silver. This is called second law of electrolysis. And then charge and mole of electrons. 1 mole of electron, then what happened? It is Q coulombs of electricity passed, then 1 F, that is called for 1 F. What is that required? 1 Faraday. 1 mole of electron, the charge that is equal to 1 Faraday, that is 16500 coulombs. That means if you pass 1 Faraday electricity, or you can say 96500 coulombs, then 1 mole of electron that is happening, used. And the product of electrolysis depends upon the standard electrode potential and charge potential of ions. That means the product of electrode, what are the products? It depends on the standard electrode potential and charge potential of each ion. Two types of battery. Next point, two types of battery. One is primary battery, secondary battery. Primary battery become dead after using for a long time, not used, reused again. Primary battery become dead, in ordinary shell, that is become dead. So then what is secondary battery? That is one, it can be reused. A secondary battery after used can be recharged by passing electric current in the opposite direction and can be used repeatedly. That means it should be recharged by passing electricity in opposite direction. The process of slow heating of, then I come to corrosion. What is called corrosion? Slow heating of metals by the gas, by the water vapor, moisture, like this. Then it is called the chemical compounds are the reaction, that is chemical reaction, that is called corrosion, and the compound in iron, that is called rusting. Water vapor is present here due to the formation of certain chemical compound, the process is called corrosion, and for iron it is called rusting, and other general process it is called corrosion happening. And then it can be prevented by so many processes as barrier protection, sacrificial protection, and other solution. That solution if you use, then that corrosion stops, corrosion can be prevented. Then come to hydrogen can be used a renewable and non-polluting source of energy. You see here fuel energy, that is mean here one is called fossil fuel and second is called hydrogen fuel, and here fossil fuel is the polluting source of energy and polluting source of energy, whereas hydrogen is non-polluting source of energy based on hydrogen economy. So here you can say the process of slow heating of metals, that is called corrosion. Then how it is improved? It is more happening, that by gases, by water vapor, by moisture, like this. And the process is called corrosion. It can be prevented by barrier protection, sacrificial protection, and so many things others are there. And out of the fuel, here there are two types of fuel. One is fossil fuel, another one is you can say hydrogen fuel, and fossil fuel is the totally polluted one, whereas hydrogen is not polluted. That is why it is very highly economy for the country. I hope it is clear to you, and please subscribe my channel Short and Sweet in Chemistry BL Das. Thanks for watching the video.